especially on the UHF side of things, you need the ability to point the antenna right towards the satellite and then be able to track it as it goes across the horizon. So not only do you have to get it pointed right to begin with, but you also have to do it across the horizon. Now, there have been some articles written that say, well, assuming you're not doing this handheld, if you're doing it handheld, then this is not even an issue, right? But if you want to point your elevation up about 30 degrees and then just rotate, that's not too bad because, you can rotate the rotator manually and kind of track the satellites, and that's what I was doing for a while. The trouble with that is that you also have to manually, unless you have rig control, you also have to manually then do the Doppler shift. Right? So your signal's moving on you, the satellite's moving on you, and so it gets difficult, especially on the UHF downlink frequencies that are typically in the 450, 460 range. So gets kind of difficult to handle it. So the software programs that are out there, and there's plenty of them, they just download automatically for you what's called Kepler Data, or TLEs. And that Kepler Data, for any satellite pass going overhead at a given time, will tell you where the bird is. So the elevation will change on the Keplers as well as the azimuth, the direction, and that allows that control software to point the rotators. Then all you need, minor detail, is an interface from your PC to make the rotators move. And then you need some feedback mechanism from the rotators of some kind, or rotors, we used to call them rotors, to actually come back so the software has a closed loop. So that way you don't oversteer, you don't understeer, all of that. So that's kind of what this is about, and how it started was that I was doing things manually just to keep it reasonably priced and see what kind of reception I was going to get. If I didn't get very good reception, then there really wasn't any sense in doing anything else with it. So I thought, well, I'll try this out. I had tried some weak signal work on VHF and UHF, things of that nature. So I thought, what the heck, I'll see what I can do with satellites. Well, first of all, there's been a lot more satellites that are amateur. I'll say amateur in quotes because you have things like FunCube and a lot of CubeSats that are put up there that only really give you telemetry data on receive. So they're not really they're not repeaters up there in space. But they've since been, the last couple of years, AMSAT has been successful in getting more launches for amateur communication. So you do have a lot of repeaters in space now for both upper sideband as well as FM. So the transponders that are up there are pretty good, and it turns out that the activity is quite great at this point. Well, that's not too hard to figure out why if you tune into HF sometimes, especially in the summer, why the activity would be as high as it is. If you don't have a lot of space to put an antenna, this is a good solution because you can do quite a bit of communications across the country, at least, not across the globe, but across country without having a lot of money in antenna installations or having to deal with the bands being shut down as they sometimes are now. So. QSOs, of course, don't last very long, so that's kind of the downside of it. But I explained why it's necessary, but basically the way these tend to be set up is in what's called a geocentric orbit. So satellites for TV viewing, right, they're geosynchronous. So they have to not change position. If people come to put the dish up on, which I think runs about 12 gigahertz, if I remember correctly, they have to have a pretty reliable general starting point with a signal meter to kind of see, okay, where can they get the best signal strength? But once they set that satellite dish up, you're pretty much good to go. whether it's DirecTV or the other one. So you get, it's a much easier situation, but in a geocentric orbit, in low Earth orbit, what you've got is the satellites are going around the Earth in a recession or progression sense, and they're making a full orbit about every 90 minutes or so. The range is up to 120 minutes, but most of them are 90-some minutes in terms of their period around. And so what will happen is they'll track across as if they were taking pictures or slices of the U.S. Each time they go around, they're gonna be shifted slightly. And some of them go to the east, and some of them go to the west.
How many are there?
About 1,500 in the sky in your position at any given moment.
Oh.
Not all of them are ham radio.
No,
satellites,
no. I was giving my dramatic pause. No, those 1,500 include military and photographic satellites.
So you're talking about AMSAT stuff.
AMSAT stuff in particular, you have, let's see, on the order of about 40, 50, which isn't bad.
A lot to choose from.
That's across all the countries, right? So you have satellites that go up, usually not one at a time. They're usually 2, 3, 4. China has 5 amateur radio satellites up there. So they're usually in groups, and they have the same naming convention as you'd expect and all of that. But all of the major developed countries have at least one satellite up there for amateur radio. So that includes the Middle East, that includes Russia, of course. Russia has a ton of satellites up there, and we do, Europe, etc. So there's quite a few birds up there, actually. And those are the ones that are active, right? There's other ones up there that are essentially dead or inactive, but that are waiting to come out of orbit.
So at any given time, how many choices do you have?
I have, for example, in my favorites list, I've got about 15.
Oh.
And that, you can sit there on an afternoon, and they're going to come up one after the other. 15's enough that.
But at any given time, you can target about 15.
Yeah. Now, I didn't put it in the presentation, but there's some caveats, of course. There's always the old adage, you're probably not going to be able to talk to what you can't hear, okay? Obviously. But there are cases where you can hit a satellite on a low angle with some power, something closer to 100 watts, for example, rather than, I think everybody has seen handheld satellite operations with a handy-talkie. Okay, well, those birds are pretty close. Okay, but if you want to hit one that's going to be, let's say, at a 20 or 25 degree angle, and it's going to fly directly over Ohio, then you need a little bit of power to get to that. Well, getting to it is one thing. It's relatively easy in terms of having more power to work with, especially if your rig already can do higher power. But you're not going to be able to hear anybody necessarily. Unless you get up in height, and unless you put an array together, even on 2 meters, it can be difficult. But these guys that are doing Earth, Moon, Earth, or doing with JT9 and whatnot, some of the digital modes, they're running arrays of like 8 antennas, and then they're running low noise amplifiers, so that, because again, the power part is easy, so you have to essentially have the preamps there to be able to pick up from the satellites that are some distance away. Because if you think about it, they're not just line of sight or around the curve of the Earth 1,000 miles away, they're also in orbit. So if you look at what kind of distance you've got to traverse, even though there's really nothing in the way per se, other than the atmosphere, it's still a fair distance. And at those frequencies, it takes some power to go a distance like that.
And are they all in 450 to 460 megahertz?
No, that's the UHF ones. They go a little lower, in fact, so they'll go down to typically about 436 megahertz for the amateur.
They're all up in that 4.
They're all in that range for UHF. And then the VHF satellites are right near 2 meters. And depending on whether, if you're talking amateur, they're right on 2 meters. They're usually at 145 or 146, but typically 145 megahertz and above. And if you're talking about weather satellites or photographic satellites or other things that you're just trying to pick up on receive, then, you know, it varies quite a lot.
Yeah. But as far as the amateur ones, you have some 145, 146, and the other 436 to 460.
They're typically transmitting on one band and receiving on the other.
Yeah, that's the thing. They have an uplink frequency to get to the set, and then a downlink frequency on the other side. So you have to have a rig. They started coming out with satellite rigs in the 80s and 90s because they could run split. Okay, so they typically don't go cross mode, but they run split between 2 meters and 70 centimeters. Oh. So you may go up on 2 meters and down on UHF, or vice versa. Typically, it's going to be the lower frequency is going to be up. But it can also be the same band, and it could be the same frequency, right? And so essentially, it's a lot like weak signal in that sense, in that you're running at, say, 145, 450, both up, and then it comes down at 145, 450. Okay. So it's just even simpler than a repeater. And that's the other thing. They typically don't use tones. So this is a toneless, non-shifted kind of entry into these repeaters. So there's no frequency shift and there's no tone. A little simple. Okay, so like I said, there's a lot of tracking software out there, but there's 2 protocols, wire protocols that are used, and that's the Yaesu GS232 and EasyTrack. Amongst 99% of the rotors, they understand that between themselves and the PC. So they're a control unit to the PC, a device. PC's the host, and they're trying to, over typically 9600 BPS serial, communicate these ASCII character-based commands to the controller. So it's a very simplistic approach as far as the interface goes, and very reliable. There's a bunch of commercial solutions out there, but the Yaesu G5500, which runs $750, is probably the most popular, and it's one of the few out there that's readily available. Some of the other ones are a little more obscure, but companies like M2 Antenna, for example, who makes a lot of UHF, VHF antennas, have both azimuth and elevation combo rotors, whereas two rotors in one, essentially.
Is that what the Yaesu is?
That's what the G5500 is. It's an all-black painted rotor that looks like your typical Cornell Doubler. So the picture I'm going to show you is going to be very similar. And then the top rotor that's mounted directly on top of that azimuth rotor, the elevation rotor, gives you from 0 to 180. Now, if the tracking software is configured such that it knows that it can do the elevation like this, then what it'll typically do is it won't have to rotate the azimuth very much. It'll just change the elevation and do one of these as the satellite is passing. So let's say you're working with 35 degrees to start reasonably, and then your closest pass is going to be maybe 85 degrees. And then as it goes the other way, it's going to be tipped up at 85 degrees, but then it's going to turn slightly, and then the elevation is going to drop, or it'll flop over if it can. Now, it's not pinpoint on when it does that, but it's close enough. It's certainly close enough. I mean, you're talking like 5 degrees, 10 degrees off. So that's why the 180 degree thing. You know, that perplexed me at first because I always assumed it was 0 to 90 and that was it, but they're actually 0 to 180. And the azimuth rotors, mine included, are 450 degrees. And that's a little easier to understand because they're south-oriented, origined. Most rotors are north origin, so they'll go from 0 degrees around to 359, right, to cover all the cardinal directions. But satellite rotors point at rest, if you will, or origined at south. And the reason for that is because then they're 450-degree rotors, they're not 360-degree rotors, and they can go 225 degrees either way. Why would you care? Well, if the satellite's coming up from the south or coming up from the north, as they pretty much always are, you can catch the satellite much sooner if you can over-rotate, essentially. Like if you're stopped at north and you're trying to point over here, you'd have to go all the way around counterclockwise to catch that, and then at some point have to go all the way clockwise to catch the rest of the travel of the path. Does that make sense? So they actually go southerly origin, so that essentially they'll point at the beginning and follow the bird till the end of loss of signal, LOS, and then they've got it covered. So it makes a lot of sense that it's done that way. I don't have mine configured that way for the simple reason that I don't have thousands of dollars invested in this, and I'm not going to lose anything if I'm not covering the whole path that AOS, where it's actually you can acquire the signal, because I can't acquire the signal until usually about 30 degrees. So it's at 30-some degrees, and then it flies over and maybe peaks at about 70, 80 degrees, and the signal's very strong, and it's almost directly overhead for all intents and purposes, and then comes back, and then I start to lose it about 20 degrees or so.
How many minutes is that?
That's about a 10-minute
Okay.
deal. Yeah, that pass for me is the better part of 10 minutes. What it'll say it is, right, with the Keplers and all that, will typically be 12 to 15 minutes. But they're starting at 0 degrees and going all the way back to 0 degrees again. So technically, or in theory, you could catch that at 1 degrees of elevation, but practically no. You can't do that. So the K3NG controller that I built was just like the VNA. It was one of these deals that was on a blog, and it had been very popular, had been out a number of years, so it was actually far older in terms of a kit or in terms of a homebrew than the VNA project we did in the Build-A-thon. But it was a similar kind of thing. Guy came up with, did the work, did all the prototyping, came up with a way to solve his specific problem, and then he thought, well, I'll make this generic. It'd be kind of a cool challenge to make it generic, and then have it so that any number of rotors, any number of controllers, secondary controllers, and all the PC software will work. As long as I can emulate GS232 or EasyTrack, I got that problem licked. And then as long as I can steer the rotors, then we're good. So he started that project about 11 years ago when he first started. And then he put the software open source out on GitHub, I think in 2010 or 2011. I think it was 2011. So it's been out there on GitHub for the last 6 years. And people have been, it hasn't been forked or branched much or anything, but people have been contributing, like myself. They want to build the hardware, and they want to program 1 or 2 Arduinos to actually steer the rotors. And then they get into it, and then you find out that it's not quite as easy as that. It takes a while, first of all, to get your head around his software. It's a pretty large package. And people have branched it, so there's multiple versions that are there, sitting there, so you kind of have to ignore them, so to speak, if you want to work with the base package. And then he came up with a way of doing a master and slave, because as sensors, positioning sensors came out, digital compasses, and accelerometers for elevation, well, they're all on I2C for the most part. Few are on SPI, but it doesn't matter. That the distance limits are not going to bring you down a tower or a pole into the shack. So you have to have a better way to do that. So essentially, he created a way to configure his package for dual purpose as a master and a slave, The slave would interface with the sensors directly over I2C, and then it would relay the information back over 9600 BPS serial, which can go hundreds of feet. If you need a little more distance, you can bring it up to the original RS-232 specification and go as high as plus or minus 25 volts. But typically at just a TTL level, 0 and 5 volt RS-232, it'll go hundreds of feet. So that's a great solution. So you can have this remote controller, if you will, up on the top of a tower, 100 foot in the air or what have you. In my case, it's 20. And then get this information back to the master. And then the master's job is to get the elevation and azimuth readings in real time, just periodically. And you can change how fast or how quickly that happens when it does its polling. The main challenge, though, aside from bugs in the software that you're going to get on an open source project, because you have so many people, so many fingers in the pie, so to speak, you're going to get some bugs. But first of all, the sensors are going to be outside. And for initial prototyping or just seeing how something works, there's nothing special you have to do. But if you're going to have it out there any length of time at all in service, then you're going to have it in an IP 6X kind of container that's waterproof. All your connections out of that container are going to have to be good. They're going to have a bladder or something that's going to seal that or be caulked. And then you got to have a conformal coating on the PCB, at least on the solder side, because you'll get no end of oxidation and tin whiskers and all of that from the humidity. It's not that the water from rain is leaking in there, but just the humidity finds its way in. You really can't seal it good enough without a conformal coating. So those two problems I've dealt with before. I learned about them in fiddling around with sensors and Arduinos. So I kind of knew about that, and I had a way to cover the conformal coating and all of that. So
really, you spray it on?
Yeah,
Really?
spray it or brush it.
Really?
But the problem I ran into, it kind of comes down to the last bullet there, is that the digital compasses that you'll get from SparkFun or Adafruit or what have you are complete pieces of crap. I mean, they're accurate to within 5 degrees, you know, and then they go, and after you calibrate them, the very next day, so let's say the rotator's pointed to southeast, and you've done nothing. You haven't had a storm spin your rotor or anything like that, right? They're still pointing the same direction, and you look at the LCD and it says 210 degrees. Well, you go recalibrate it, and you're right back to 135 again. I said, well, heck with this. I'm not going to keep recalibrating that. That's ridiculous. And I found that the cheapest one is made by Honeywell here, hometown company, that costs about $200. And it is not only accurate, but stable as well. So that's the kind of money you're talking to get into a digital compass to have, again, not so much the accuracy, because a few degrees either way is not a big deal. But that whole thing of, well, I didn't mention the other thing, is nonlinearity. As it went around the dial, you had to calibrate or correct for nonlinearities. And every one of these digital compasses that I tried had nonlinearities to them. So you might go and say everything's great within east to south, but then you check it from south to west, and it might move a few degrees, and then all of a sudden jump 20 degrees. So, you know, you're running into some weird stuff. I didn't see that the compasses were affected by EM from the circuitry at all. I had it on the bench. I tried different things. But the nonlinearities were still there. And I found out about the stability problem as I had it on the bench longer, and then it was sitting and, you know, go from day to day to day. So, get the credit card out. I ended up buying a G450, which is essentially just an azimuth rotor that covers 450 degrees, so it's for satellite work for azimuth. And you'll see my setup in a second, because I think I had mentioned at a previous meeting that I had acquired an Alliance U100 rotor, and the whole idea of that was for elevation. So I had 2 rotators I had to control, but the big thing about the G450 is not the 450 degrees. That's a nice feature, but it has a precision wire wound rheostat that spirals up, so it can cover those 450 degrees and never get hung up and not corrode. So I was like, okay, I get that, I hooked that up, I calibrate it once, and it's been dead on ever since. And I mean to a degree dead on. It's that good. So it was worth the money. It was a lot of money, but it was worth it. As I mentioned, the other real challenge was just the bugs in the software package. I found and fixed 5 of them. I communicated that back to this guy, Tony, no coincidence, same name as the VNA, and he put the fixes in the next release. But they were, I mean, a couple of them were commas instead of dots, just really stupid stuff. And I thought, well, why hadn't those been found before? Well, it was a combination of other people adding in enhancements to the code base, and the fact that no one had this exact combination and really wrung it out. And what I mean by that is that the U100 has an interface that essentially is a cam, a metal cam inside of it, that bumps up against 2 copper straps. And when it hits those 2 copper straps, it goes to ground. So pin 4, it only needs 3 pins to rotate either direction, like most of these rotators, but it needs to hit that ground, and it does it every 10 degrees, as it turns out. So every 10 degrees it hits that. And that's because the original Alliance controller that sat on a TV actually has a solenoid in it, and when that pin grounds out, it pops a solenoid, which just about makes the box jump off the table. It pops the solenoid to advance the dial 10 degrees. And that was the scheme that they came up with to keep the rotor in the control box in sync.
Really low cost, simple.
Yeah. And a lot of people have loved it. Well, to modernize that, I had to essentially do an opto-isolator with it, because there's a lot of 60 hertz that comes through that. So I opto-isolated it, brought it into a hardware interrupt pin, and then when the hardware interrupt triggers, it knows from configuration, and this is where the flexibility of the software comes in. It knows from configuration that means 10 degrees. So if I push the elevation button, which is the one on the left, up, it goes up, and it goes up 10 degrees. If I'm at 0, as it's showing there, it's hard to see, but it's at 0. If I try to go down, it will not go down, because it has limits. So that's configured in as well. So it knows 0 is the limit. It knows plus 90 is the limit for that particular rotor, and it goes 10 degrees at a time. Side note, you can take the cam out, and there's other things you can do that people have done. They've put magnets on that cam to do a Hall effect sensor to give you 2.5 degrees or whatever number of degrees you want. One guy put spot welded another nub on there, so essentially you got 5 degrees out of it, because it would ground out twice per rotation. Things like that. So there's some things you can do with it. But if you recall, I got that rotator for $60 on eBay, and it had never been used. It was sitting in the box in a basement or whatever for years. The box was almost falling apart from dry rot, but everything inside was brand new. And I was like, well, I could spend $750, or I can spend about $370 altogether in rotators, which wasn't planned. The original plan was to use my Radio Shack rotator for azimuth that I had been using, but that had no feedback. That's why I went to the magnetic compass initially, to give me the feedback for what direction I was pointing in. Had that worked, I would have been set. I wouldn't have had to buy another azimuth rotor, but such is life. Built into the Yaesu rotors, well, the rotors and the controllers, is an over-rotation thing as well. And that's just to let you know that you're in that over-rotated spot from 360 to 450 or from whatever it is, 225 to 360. So that's just a visual indicator, which most people kind of ignore because they have hard stops. Rotors always have hard stops, so it'll stop at east or stop at west or what have you if it over-rotates. But it was another pin and a resistor and an LED, so I threw it in there. The inside of the box, I would have brought it, but I had so much other stuff to bring, I didn't feel like hauling it in. But that's an Arduino Mega, so it's a little bit bigger Arduino board. It has more I/Os is the main thing. And because I was originally using an Arduino Nano as a remote unit, I had to have at least 2 serial ports, and you get 4 on a Mega. So I had to have enough serial ports for that. Serial port 0 that goes into the Arduino to program it or provide terminal is what is the line that's used to send the GS232 commands across for the PC software. So you get that no matter what. But if you're going to have a remote unit, you have to have the other serial lines available. There's different ways to accomplish that. But the bigger problem is that this package has grown to the point where it doesn't fit. It doesn't compile and fit in an Arduino anymore. When I put it in the Nano, I had to strip a bunch of stuff out manually to compile it to get it in there just to bench test it. So a Mega is really, the way to go. And most of the guys that have been building this, per the forum on Yahoo, are just using 2 Megas, right? Whatever. They're $50. I mean, they're kind of pricey, but. So the wires are just the I/O, and again, apologize for the picture. It was a little cloudy when I took this, but the GS450 is this guy here, and the Alliance rotor is up there. And if you remember, the Alliance rotor is the only one that has the mass go through it all the way. Most of them have a mechanical stop, and they're meant to be mounted vertically, of course, to turn a AM or a FM TV antenna, right? Well, this one, the shaft or the mass goes all the way through it. So hams have been using the U100 for an elevation rotor for a very long time. I mean, 30 plus years. And this is there's a company called Arrow Antenna out of Montana, I think it is, or Wyoming. And Arrow Antenna is usually at Dayton. And these are meant to be handheld. They actually come with a handle on it, so I had to make an adapter bracket to get it to mount on the mast. But they're very good antennas and highly recommended. It does a great job.
Is that the longer one with 4 elements?
Yeah, I got a 4-element for 2 meters, which replaced a 5-element that I had. So it's not quite the same, but it's close. And then there's a 10-element 70 centimeter on vertical. Now, if you're really hardcore satellite guy would say, well, you need another one of those so you can flip the 2-meter vertical and the 70 horizontal, but I'm not hardcore. Up here, I've got an omnidirectional 2 and 70 centimeter. Up here, that's my satellite bullet antenna for GPS. And that's an FM antenna because I sometimes listen to FM stereo. So that's all of my high frequency stuff there. And I have an off-center fed 40-meter antenna that you're seeing the beginnings of here. And right here, you can kind of tell there's a little piece of ladder line showing there, and that's the one that I use on 30 meters for Whisper.
What's the elevation? How far above the ground is it?
Yeah, these guys are about 23, 24 foot.
Is that on a little tower, or?
No, that's actually heavy conduit. There's light gauge conduit, which is fairly thin wall, but there's also heavy gauge conduit that isn't as heavy and it isn't as thick walled as, say, black iron pipe is. So that's what that is. That's the thick wall heavy gauge electrical conduit, 2.5 sections, almost 3 sections, and the bottom section is concreted into the ground. And then I have several ground rods on it, you know. And then the same thing, there's another one of these on the other side of the house because of these guys. This used to be a 15-meter antenne, whether or not, I mean, it'd be great to have a modern rig that'll do VHF and UHF, even though there's only a few of those out there anymore. But that's a lot of money to sink into something like this, so I don't know if I'll do it. But it was a great project. I mean, I swore at it a number of times as I was doing it, but in the end, it was a nice project to work on.
That's great.
Questions?
Thanks, Russ.
Okay. Oh, Dan, I'm sorry, you had your hand up.
This is a little bit different than maybe your project itself, but I'm perplexed. You were telling me that the amateur satellite's only basically operating 2 meters and 70 centimeters?
Mm-hmm. There are a couple exceptions to that. There are some old Oscar satellites that downlink to 10 meters, and there are some newer satellites that go uplink or downlink on 2.4 gigahertz.
Okay.
10 meters to 15 meters even.
Sometimes 15.
An
Yeah.
old one, that's why I used
Nothing
to do
on
it.
Yeah, Oscar 7 is still operational. It goes
6
down to
meters
10
is not a
meters.
worldwide band, so
Okay,
there's no incentive for you to put a worldwide satellite on that band.
Okay, thanks.
So, I thought about, this has always intrigued me, and my home right now, the front of the house is south, the rear of the house is north, and I've got trees to my east and my west,
Okay.
and if I do anything in the backyard, I really don't have good exposure to the south. And if I do something in the front yard, I don't really have good exposure to the north because the house is in the
Yeah,
way.
both are a problem. Right?
So,
You have to get up. In your case, you have to get up high enough to get over that.
yeah.
Yeah.
So I got, so my conclusion, and I'm kind of drawing it again, is that what I need to do is it needs to sit on the roof
Mm-hmm.
some
Yeah, or
kind of
next
way.
to the house like this does.
Yeah.
Yeah, either or.
Yeah,
And you got to get, like in my case, I had clear view all 360.
yeah,
But in your case, yeah, you want to, on 70 centimeters, you can't go through the trees very
Yeah.
well, right? 2 meters, no problem, you know, but 70 centimeters is going to be a problem, although that's more of an issue if you're working line of sight, which might be a repeater. That's not going to be a problem in the cities here, but weak signal, you know, might be. Now, that said, there aren't a lot of people on weak signal. Okay, there just aren't. Northern Lights members get on for contests that they have, and that's about the only time they're on, it seems. They don't run, there's a couple in nets, one on 432 and one on 6 meters. I think those are the only two that are active now. And they're check-in nets, right? So they last about 10, 15 minutes. And they have, as it is, they still have weak signal people from Wisconsin, Minnesota, North South Dakota, Iowa, and Illinois on those nets, because that's how far their membership spans in Northern Lights, and Canada as well. So, you know, some of them have enough invested with 80, 100-foot towers and big arrays, power, low noise amplifiers that they can work weak signal, you know, and it's still an option for them, even though there aren't a lot of folks on it. They get on when the contests are running, and they get a kick out of it. There are also people that run weak signal off the top roof of their garage on a tripod, because if you have the visibility, right, the height is always better up, of course, but it's not absolutely necessary either. So.
And the satellite people, there's quite a group of them that are grid hunters and grid chasers.
Oh, absolutely.
And so, and there are people who will
Yeah.
go out and do expeditions to rare grid. They'll set up on grid boundaries.
Yeah,
And
absolutely.
so, if they're on reflectors that I see, every week there's somebody, I'm going
That's
to be
right.
in this place
Yeah.
at this time, and
That's right.
these satellite passes will be available, so anybody wants
Yeah, I
to.
should have mentioned, that's really pretty much the basis for
Yeah.
continuing the contests on VHF and UHF.
Yeah.
Is someone's going to volunteer to go rover, and then Northern Lights, there's, I don't know, good 3-4 people that'll go out roving. They
Yeah,
have
but
the setups.
The satellite guys will do that too. A lot
Yep.
of the satellite guys.
And they'll go to a rare grid, and everybody wants to talk to them. You never know, someone you don't know.
And it lends itself to that since they're relatively, 5 to 10 minute passes.
Yeah,
You work as many people as you can per that pass, and you wait for the next one, work a few more, and then move to the next location and do it
right,
again. That's what it
right,
takes.
right. They coordinate their schedules. They send spreadsheets out and the whole nine
So what's the
yards.
period then, or how long does it take to get around?
About an hour and a half.
Yeah, 90 minutes give or take. Yeah, and then it's moving a little bit each time. So you may get 2 or 3 in a row, and you'd be across the U.S. and it's got to work its way around the whole world. And then you get 2 or 3 or more.
They're elliptical orbits though, aren't they?
Yeah.
I mean, so you,
Well, they're
Not real elliptical though.
yeah, not really.
Really? Okay.
No, you're thinking of like an Oscar 10 or Oscar
Yeah,
13. Those were what we call high elliptical orbits. These
Yeah.
are low Earth orbits.
okay,
Yeah.
okay, so these
So-
are pretty.
So
pretty
these are
nice then.
circular,
Pretty much circular.
on the
Okay.
order of
But
what
polar.
you see from the space station. roughly.
Okay.
Their precession is at an angle, South Pole, North Pole, and then drifting like this. So like I said, it's almost as if you imagine them with a camera on, taking pictures, it would be like a strip, right? A strip of pictures
Yeah,
and a
right.
strip of pictures and a strip of pictures. Yeah. Yeah, it cracks me up the coverage on the different websites. Like a satellite will come into AOS, acquisition of signal, and they've got its footprint. Well, its footprint is like the whole United States. And I'm like, well, no.
That's from zero
Not
elevation
actually.
to zero elevation. Yeah.
Yeah, 0 to 0, and there've been days, especially on the weekends, where you get a fairly popular satellite like FunCube or one of those that there's a lot of people on. All of a sudden, you'll start hearing people from Georgia, North Carolina, and just all over the place. Whether or not you're going to get back to them, you have to see, but you will hear them.
So you normally work people north and south of you rather than east and west?
Doesn't matter.
As long as they can see the satellite, if you can both see the satellite, you can talk.
Yeah, it's really a lot like on FM
I guess
especially,
so.
it's a lot like a repeater antenna being, 20,000 feet in the air. I mean, it's just,
Yeah.
it's great. But again, you've got to get through atmospheric layers and water vapor. And on UHF, again, that becomes a challenge without a lot of power. Some of these guys are running 500 watts, but
Well, the other thing you should mention too is there's 2 different types of transponders. There's
Yeah.
single channel FM transponders,
right.
where whoever's got the strongest signal is the guy that's going to get heard, right?
Right.
Because there's the FM
The
capture.
hogs, right?
Yeah.
Hogs, yeah,
And then
absolutely.
there's transponders, which are like your old UHF TV translators, where it's
Right.
got a band of frequencies and it's taking a snapshot of this and it's repeating them out.
Oh.
And there you can have CW or sideband signals simultaneously. The only problem there is that all of the power for the transponder is shared. And so you get
It
some
is.
guy comes in with 500 watts, everybody else is going to go down, you're not going to hear him.
Yeah.
And so there's a lot of careful practice that should be followed not to do that. But
Yeah, they really recommend that you don't use, they start at 5 watts and work your way up, which is probably right. But again,
Yeah.
it's 5's a bit of a challenge. Like that Yaesu rig will do 25, and I'll typically run about half of that, and I'm fine at about 12 watts. I'm fine.
What modes?
FM and upper sideband. Yeah, and then telemetry is all over the map. I mean, the telemetry really depends on how old the satellite is. If it's a newer satellite, it's going to run AFSK or even PSK for the telemetry down. And if it's older, it's typically going to run something that looks a little more like RTTY. So, FSK.
Low power is better to try in 2 meters then?
Yeah. Yeah. I mean, there's enough 2 meter satellites up there with low power that if you look on YouTube, you get home and you look on YouTube, you'll see a bunch of videos on there, guys with handy talkies you know, that they might be 2 meter and UHF, but oftentimes they're just 2 meter handy-talkies with a handheld antenna, much like I showed, and they're working satellites, no problem.
That's what I have.
Yeah, yeah. You have the antennas yet?
No, I mean, I have a Yaesu VX5R.
Yeah. Now again, it's simpler because you don't have the tones and you don't have the frequency shift, so you have to make sure that you have those shut off. A lot of times you're not going to because of the repeaters that you're set up to work. You shut all that off and then work them straight. Know if there's a different downlink frequency, then program the handy-talkie to shift on receive, transmit on a different frequency. Not all of them will do that, but most of them I think probably do. And that's about it. You just have to know about where it's going to be in the sky and when. And that's published several days ahead of time, actually 10 days ahead of time. So you'll know where it's going to be in the sky.
Yeah, the best thing in my experience is to get one of these handheld antennas, beam antennas that you can physically move around and point at the satellites manually, and get a little coax and an SMA connector for your radio, so you can connect that antenna up to your radio, and tune it to the approximate frequency, downlink frequency for the satellite. If it's early in the pass, it's coming towards you, so there'll be Doppler shift higher than that frequency.
Yeah, a little bit up.
After it passes you, the frequency will be a little bit below this nominal frequency because it's going away from you. It's like the train whistle, right? It sounds high when it comes in. Radio waves do the same thing. But if you can then there's a website called Heavens Above. And if you can look on that website, type in the satellite name and your location, it'll give you a table you can print out of this frequency, this azimuth, this elevation, and that'll get you close so that you can sit out on your porch and, you know, point at the thing and tune to the frequency and practice just listening to the downlink.
Yeah, exactly.
And you'll hear it, you'll learn how sensitive is it, you know, how close do I have to be to get it, and it varies on UHF or VHF.
Yep, and then what's your polarization? Big advantage of that is you can rotate this way.
For maximum sound, yeah.
And then as soon as it sounds great, just hold it there. And then if you get to the point where you get the lingo down, it's kind of somewhere between PSK and standard
There's
voice.
short transmissions.
Yeah, it's short transmissions. There's a little bit of shorthand, but essentially you'll say your call, what grid you're on, and then wait and see if anybody comes back.
Yeah, but that's kind of the basic starting point. Is listen a lot, and get used to tracking them and changing the frequencies as it comes and goes and that sort of thing. Get a feel for that, and then once and you can hit through, listen to 3 or 4 different ones, like you say, in an hour, in an afternoon. And
so you'll need an antenna, and you don't need a bigger one like that. You can actually get one that's got maybe 3 elements on 2 meters, and just 2 meters, or 2 and 70 centimeters. 5 element on 70 and 3 element on 2 meters, and that's what most people use handheld. It's fairly lightweight. You're not going to get your wrist too tired if you're going to be out there for a while.
And then once you get comfortable with listening and tracking it, like I say, you need a few extra hands sometimes.
Yeah, absolutely.
A lot of times, and then you can try transmitting and seeing if you can hear yourself. That's the next big step.
Yep, that's right.
You got to be able to hear yourself because it's a repeater and it's full duplex. You're transmitting and receiving at the same time.
And there's enough of a delay that you'll be able to hear yourself.
Yep. And then if you can hear yourself, that means everybody else can hear you too. So then you're good to go.
And that's what I started with. I mean, I started with a handy-talkie and FM only with satellites. Even when I put the antennas up initially, I was just FM.
Yeah, that's why a lot of the guys that do this on a regular basis, the portable stuff, they have a voice recorder plugged into the headphone jack of their rig, and they wear headphones because you're full duplex again. So when you're transmitting, you're receiving too, and you get feedback and echo if you don't. But they plug in a voice recorder so that they can record the whole pass and then log it after the fact. Because you got a lot of hands, a lot of things going on for the 3 or 4 or 5 minutes you're doing.
If you're going to log the QSOs, absolutely. Absolutely. Plenty to do. It's a lot like contesting in some ways, even though it's not a contest per se, but it's got some similarities.
It's quick and snappy,
Yeah, quick.
How powerful are the satellite transmitters?
They vary. I think most of the UHF ones are under a watt. And VHF, not too sure. But
Yeah, that's what the receive side is very, on the ground, your receiver and antenna
yeah,
are a very integral part of making this work.
Absolutely.
Yeah.
Yeah.
Because they're working off of solar cells and a small battery.
And a battery,
Yeah.
right. Yeah, and the CubeSats especially have the solar cells on the outside of the cube. And you know, sometimes one antenna for just UHF or a pair of antennas, and they're just little whips, is all they are. Right? They can't have anything too fancy. It's gonna, because every I don't know, tenth of an ounce or micro ounce counts in a payload. So they're very fussy about how heavy those things are. So yeah, but it's very cool. I mean, especially I mean, I've been doing receive side stuff for most of my life. So when you start looking at weather facts for maps and telemetry for things like FunCube and whatnot, some of them have dedicated apps. So when you get the telemetry down, the application does everything for you. It decodes everything, puts the right values in the right fields, you know, on a screen in a form. That stuff's pretty cool. I mean, it's not something you're going to do, you know, sometimes more than once. And it may take a while just to get to that point where you have been able to do it once. Just to get a CW decode that you can copy on a satellite for its call sign can take you 3 or 4 tries before you get it. Because it's got to be unbroken enough that you're going to get the whole call sign. So it's, I mean, as far as ease or effort goes, PSK digital mode is way easier than this. I mean, it's way easier. That's pretty much just type and go. But this is a little more technical. There's a little more to it, and definitely some luck involved as well, along with getting the rig. There's a rig, you can do the handy-talkie outside with the handheld, but to go from that level up to a base station, the price goes way up. Yeah, it goes way up. So, but it's fun. It's just another mode to take advantage of that we have privileges on.
Is it pretty crowded when you hear a pass?
Not too bad, although the big guys definitely in a good grid location, let's say, they'll get a pile up. But a pile up on satellite, to me, I'm not hearing what they're hearing, obviously, but I'll hear 3 or 4 callbacks.
And they space them out a little bit away from the base frequency then?
Yeah, they try.
Depends on if it's FM or not. If it's
Yeah,
not,
exactly.
FM is a one channel.
Yeah, it's one channel you hog. But I usually work upper sideband and pick a slot.
Yeah.
Go up a couple KCs or whatever?
Yep. So you hear somebody, or you transmit, you know, taking Doppler shift into account, right? Which is more art than science, really. I mean, you can let the software do it, but you can also do that manually, and then just you get used to about how much based on where it's at in the sky. And I don't know, but Jim, I find that when they're going away, it's much easier to lock onto them than it is when they're coming in. It seems like when they come in, they're on top of you so fast, and then when they're going away, you sort of have a straight line, and the elevation's dropping fairly slowly. And I've done more QSOs on outgoing than I have incoming.
I'd have to say that's what I've seen too.
Yeah.
What's the repeat time? Up and down?
Boy, I
It's
should know
quick.
that.
It's low Earth orbit, so it's more or less instantaneous.
Yeah.
There's maybe a quarter
So you
second.
hear yourself when you say, but it's really short.
Yeah, it's really, it's not like
Yeah,
the
the
big,
delay.
the older high Earth orbit ones
Yeah,
where it could
okay.
be a
Right.
couple of seconds.
Okay,
And this is
Right,
pretty
right.
quick.
I see. Okay.
Yeah, you get on duplex, you'll hear yourself as you start to talk. It echoes like he said,
But you do
because
it.
it's too close. It's just like almost in lockstep, but not quite. So it has an echo effect. Yeah, it's fun. All right. Anything else?